Hello everyone, I hope you all are doing well. So in the part 1 session, I had covered FSAE body, that is the Wellman structure design, how to do it from the scratch. And in this session, I'm going to deal with the body design and the safety analysis using the SolidWorks flow simulation. Let's get started with this. Okay, so this is the model. Uh, to just avoid the time usage or the performance log, I'll just convert this one into a step file and I'll reopen it. Yep, so this is the step file. This is fine. So if you want, you can break the links. You can use the import diagnostics. This is fine, and just break the links. Yeah. So the model is ready. The thing is, I need to create the enclosure for this using surfacing or whatever the method you are looking for. For my convenience, what I'll do is I'll refer the one of the case study from the internet, and from there I had grabbed the few of the images, so that I'll just attach to the sketch, and I'll try to recreate the same design so that we can do the uh, safety validation by using the same case studies. Okay, so these are the images which I had downloaded from the internet, referring a few of the case studies. Yeah, so you can rearrange the model, the shape according to your frame. So same thing, you can add the top views and front views. This is fine. Let me add the top view. So go to insert, sketch tools, and tools and sketch tool. Show the top. Keep in mind, you can even turn off the aspect ratio matching so that it should perfectly match the wheels, and the front view, right view should properly align. So next thing, I'll just use the same images to copy the profile. You don't need to take the same exact copy of image, because as per our development structure we need to design it. So I'll refer the approximation of this design. So this is the line on the top, and I need a line for a reference, so that front part I can create it later. So remaining everything can just copy from the sketch. So it's just a rough design. It's not like exactly the same for design for manufacturing. We're just dealing with the approximate design and the validation by using the solid flow simulation and the SolidWorks design tools. Yep, here again, I'll take the draw frame references. Yep, this looks fine. Thus, you can just take it as construction, and wherever you need to fill it, you can add it So at this corner, I need the fillet to have this curvature. Can just increase the size. It's approximate. So same thing I'll add everywhere, because if you want to add the fillets and all later, these values will help you later on. Here P1 at the bottom, I'll do the same thing. The radius is more. Let me just reduce it. Yep, this is fine. Just increase the radius value a bit. This is fine. 40. Yep, the cover case is fine. So by referring the side view, you can able to draw this. So now I need the chassis design. For that I need the front view. So on this, we can add the sketch so that you can refer the image and draw the same. Let me do the same thing. This is fine. Go to tools and insert sketch picture. Need the front view. Just locate it properly, referring the previous images. This is fine. Now I need a plane which is perpendicular to this line and point. So at this place, I need the front curvature. For this, and by just looking at the image, you can just replicate the same. So instead of drawing whole thing, I'll just draw only half side so that I can mirror this side. No? Oh, let me do the same thing. The origin, can drag it out. And take rough guesses. Later on, you can adjust the size and dimension. So as it's a front view, it should cover the front Bellman structure. So it should be something should be something more than the height of the frame. So I'll refer this. So instead of drawing everything better, half is fine. Yeah, fillet needed. Increase the size up to 70 or somewhat. Yeah, same thing. Here, one more reference line, I'll take it. So I need a plane here as well, so I can create it. This would be fine instead of that. Yeah. So next thing, to create the plane, you can refer this point and this line. The plane is ready. So on that plane, I need to sketch one more profile. Sure. So you can refer this at this place. The shape is slightly bigger than the initial one which we had drawn. Yeah, it should be somewhere away from this frame, slightly larger than this. This is fine. Now you can repeat this. Yeah. So this design is quite okay. No issues. Adjust the size. Make it vertical if you want. The tangent will also work, but the design will look quite complex as we are just dealing with a simple design. You can just make it as simple as it is. You can yeah, the top view I need to refer, and I need to draw one more reference guide curves. So I'll do the same thing. You need to refer the sketch because you are using the loft. The guide curve should lie on the profiles as well, or else it will create the errors to design lock feature. So I'll take this rough approximate sketch. Later on I can just modify this. This looks fine. Now you can just hide these all the images. Later on you can just, if needed, you can just activate them. Just click on the sketch and hide them. So now you can even hide this all, but let it be. You're done. Everything is done. Now you can refer these profile and the guidelines by using the loft tool. This line, green check, as you could see. I had taken 3 guide curves as a reference, and this is fine, no issues. Green check. You can mirror it later. You can use and try once if you want. You can use the bodies to mirror and just see. This is how it looks like. Fillets needs to be applied. Few modification needs to be done, and front the aerodynamic shape also should be created. So that will do it. I'll just activate all the sketches again so that I can refer them to create the further design requirement. Kind of design by using images and tracing images will be better if we use the surfacing. But as design is quite simple for me, as I'm looking, I'm just using the features. I'm gonna draw the front dome. So on the top plane, I'll just draw this reference like this. So fillet is needed. Putting out the shape. Can even close the sketch to just use the multi-body tool, that is combine. In Katia, this tool works with magical things. I love it. Yeah, let me just close this. So as I'm using the SolidWorks connected, you can even set the shortcuts as you do in SolidWorks. So I'm having it, so it is quite user friendly. Right now I need to use the combine tool. For that we need to extrude the models first, the features first, and then you can use the combine, and from there you can just use the common tool. Yeah, so you can use the extrude tool and just extrude these two sketches. The sizes doesn't matter, as we are using the combine tool, only the common features will be saved. Features and combine, as you could see, as it's a multi-body, it's a single solid body, so I need to activate into multi-bodies. So I'll just uncheck the merge results so that these two will be separate solid bodies. These all advanced multi-body tools will work only if you have the multi-bodies inside the model. Yeah, fine. So now you can go to insert features and combine, and select these two and use the common figure. So this is what you get. Yeah, you can make the modifications into this by just changing the profile to get the final shape. But I'll do it. Now I'll apply the flat. I'll take same 70 as I took before. Before that, this front shape should be curved, right? So you need to make the changes to get the final shape like this instead of the straight slotted face there. Let me do some changes here. Yeah, these two should be coincident so that that particular slotted structure needs to be eliminated. Let's see now. If you want, you can just simply add the curve instead of straight line here to have the better the dynamic shape. Now this looks fine. Yeah. Yep. So this is fine. Now I'll refer this face instead of drawing the sketch again, and I'll use the convert into text to get the same output, as I need to draw the remaining body cover structure. I'll refer this, and no. What I'll do is I'll just use the sketch only as a reference point, and I'll simply draw the reference out like this. As anyway I'm going to trim this top portion, and this is not needed to be perfect. Like this, you can take it as a reference. So anyway, I'm gonna use the same tool, that is loft, to just extrude this as well. So you can add multiple kite lines. So here, let me just utilize the previously created yeah, sketches. This one, so you can just show it. You can refer this one for drawing the back rear casing. Now this reference, right? So you can use the tool from here to, you can draw it according to your requirement here. Even drag it out up to a certain distance, or if you want, you can take the angle here only. So let me drag it up to here. This is just a path line for loft. Yeah, so I need one more profile to use the loft tool. At this point, I'll create the reference plane first, perpendicular to this line and point. Just at this point, this is fine. Switch on it. Just refer the same face again and convert it to build work. Yep, remember the guidelines and the other, like all the three guidelines should lie on the sketch, or else you'll get the errors. So I don't want the fillet now itself. Later on I can apply, can remove it, make it construction, and just this shape. Now even the bottom structure, extended one, we need to have it. I can't have the straight line. Yeah, so trimming this, it doesn't matter the distance and the where you're placing it. Now I need a straight line again to have the path to guide them, or else it will be a irregular shape once you loft it. So just refer the straight line for the propagation. So you can use the PS relation so that it should lie on the sketch. Perfect. Now loft, you can use the two profiles, this one and this one. At the guide curves, clear the selection and select them properly. This is the first, second, this is the third one. Perfectly fine. Now the entire sketch is ready. Now I just need to remove the extra material. That is very important. Can use the sketch references. I'll draw the cut section area. So this time I won't draw the sketch again. I'll refer these previously created sketch edges as the references here. Can hold the control and select all the edges. Just go ahead with the convert entities tool and just extrude it outside and remove this material. As we're not concerned about the outside one, don't worry about the shape. Go to extruded cut. Just reverse the direction. To all both is also fine, but just reverse one direction. From feature works, you need to select only the body, the model. You don't need to select all the elements because it will also eliminate the element structures. So you can configure that one later. So I need to remove the bottom material also. So I will draw the sketch. I'll refer the same profile again. Convert entities and then just close the sketch and remove the material. Yep, so okay. Recheck. Yep, so you need to make some changes to how this all the element structures into account. I'll hide these all the sketches and even the yeah. So here instead of selecting auto select, you just select this body because we are only concerned of this, not the element structure. Okay, I'll try to recreate this as it is removing all the elements. So I'll use the blind this time. Just replace it. And now feature scope, I'll just select only this body, not everything. The thing is, while drawing this model, the extrude, it has combined with the Wellman structure. So there I need to just unmerge the result so that I can have the effect here. So as you could see, all the Wellman structures also got added there. So here I'll just use the merge results uncheck, and now this will work fine. When I go cut the material, it will easily remove it. On this lock also I need to do the same thing. Yeah. This is fine. Green check as I could see. Still it is removing the material. Let me just cancel this in the selection, auto select cell remove, and I'll just select only this body. Now let's see. Yeah, this works. This worked. Same thing at the bottom, extruded structure, reverse the direction, uncheck, auto select, and just select this body. That's all. Now the final design is ready. You can hide all the sketches and planes. I just need to create the shell. Now to do that, you can activate the shell tool and just select the faces. Thickness, I'll take it 3 now. Let's see. The faces to remove, just select the faces which and all you want to remove. These faces are the main priorities which I don't want them, so I'll just select these all the faces. Yeah, this is a multi-body, can't select that. These are all the tangent faces needed. Yep, all got selected. Green check. Yep, you could see. This is how the structure looks like. Thickness is slightly less, I believe it should be more than 50 mm. At the moment, I'll keep it less. Later on, we can modify. Just keep it 5 mm. Green check. Yeah. So now, and to create the interject the contacts as well, it is not interferent. Fine. If I increase the thickness, it might. Again, just take the control on it later. Let it be. So now, this extra face also got remained here. What I'll do is I'll activate the shell, and even I'll select this face to remove this particular inconvenience. So how to select it? Just hover on the same face where it is, just use the select other, but we'll just give it the face selection. Green check, that's all. Yep, that's gone. Now here I need to create one more shell. Use the shell tool and remove these things. Just great. The structure looks great. Here, yeah, on the front solid body also I need to do the same thing. Yep, here is something I need to make the changes. You can just roll it back. You can apply the fillets here as well, so that it should match the previous design model. So as we don't have the fillets at the sharp corners, it is giving the error. So instead of these edges, I will apply the fillets for these. So these will give me the great impact on the filleting the corners. Yeah, now I can try applying the fillets. Yep, not taking. No, not to worry about it now. It's attractive, right? Yup. So I just roll it back and make some changes into the errors. If you get it, shell 1 has the error. You need to clear this. So edit this feature. Just check the face which is remaining. Yep, the bottom face. I need to select this as well. Green check. Yeah, finally you can just shell this as well. Instead of that, let me just mirror everything. Instead of features to mirror, use the entire body to mirror. Yep, this is fine. Green check. This is how it looks like finally. Just remove this and apply the appearances. So I had already created the shell inside for the front aerodynamic shape. So I'll apply composites as practically it is made of composites. This is how it looks like. I'll try other. No, not so attractive. This is quite good. But anyway, it's better to deal with the appearances only instead of composites. So to do that, let me just assign the appearance for this first. Metal. So you can just select this and just drag and drop it here. You can close this. This is not working, so I'll directly drag and drop it. I'll select the feature. The body, entire body can't do it. So what I can do it here is only for this it is applied. I'll select all the imported bodies and I'll just paste the same appearance. So you can do it from here to here. Hold the shift, select all, paste appearance. So automatically it will apply the same appearance to all the well-known structures. Great, right? Now I'll simply add the appearance. So this time I'd go ahead with the paint. This doesn't work. They're not that much good. Yep, this looks great. Now the model is ready. I don't want the structure. I just want to delete this because it is extra extended portion. If you want, you can have it later. I'll use the center rectangle and remove this. This is not the way the professionals use, but I believe these are the shortcuts. I can follow the same thing. Even you also can follow the same. Yeah, you can use the 3D instant to just define the dimension. I'll just increase the size a bit. Yep, it's great. Yeah, selection, just select the components which you want to remove. Yep, done. This looks great. So I need to run the analysis. Before that, I'll save this. I'll create the assembly for this. I had downloaded a few of the components from the website and the Google. So you can simply drag and drop the components which you had downloaded it, so that you can just save your design time by using the pre-made design. So all the stuff files I'm having it here: seat, steering, and left wheel. Click OK. So all got selected once. It has some issues as they are stiff files. I'll bring one by one. So for importing, it shows the like I need to break the links and all. So for that reason, it won't select all the models at once and bring it back to the assembly workbench. I'll take one by one. Yeah, seat is needed. Yep, all the components are available, so I don't want to assemble them now. I'll just fast forward it. I had already assembled them. To save time, I'll simply just fast forward it for your convenience. Yeah. So this is the final assembly. I don't want engines and other stuffs and all, because as I'm just dealing with the flow simulation to check the track force, according to the literature survey, I just want to validate it whether it is fine or not. So only the structure I'm considering. This is F1 or FSAE car model. So we can just start with a new wizard, name it as safety analysis. Got it. Next, mmgs I'm gonna use. Velocity in kilometers per hour. Next, external floaters. If you want, you can define the gravity. Remember, you need to have the SolidWorks flow simulation license to run this flow analysis. So I'll just make the gravity downwards, y direction, fine. External gases, fluid, I'll take it as air, as practically we have the air only. Laminar turbulent both are active. Adiabatic wall, no issues. Yeah, here velocity I need to define along x direction, so I'll take it as maximum 120 kilometers per hour. It can run up to 140 kilometers per hour, but I'll take it 120. And with respect to that 120 kilometers per hour, I'll check the drag force instead of using the CD. CD calculation here is manual. I need to enter the formula, and I need to add the all the surface areas and all. It will take some time. So I'll adjust this all the computational domain. You can even use the advanced mesh refinements. I had already created the tutorial on it, how to use the advanced mesh to have the better results. And this is fine. I need to define the goals, but and all I'm looking for mesh. You can use the direct automatic mesh here. Instead of that, you can use the manual one as well. So for now, time convenience, I'll use the automatic mode, level 7. This is how the preview looks like. Quite good. Yeah, goals are defined. Insert global goals. You have the multiple types of goals. At the moment, I'm just looking for the track force. That is, I'll take the velocity as well. For my convenience, you can use the maximum and average velocity. Force, which indicates the drag. It is not normal force. It is force along y, would indicate the drag force. Force along x indicates the lift. So at the moment, I'm only concerned with the drag force. This is fine. Yep. Check. And as well as on the boundary conditions, you can just simply run this. You can even hide the computational domain. It will take some time to get the results. 150 iterations. I'll just preview the results. I'll insert the cut plot. I need the velocity plot. Could see this is how it is. Even try with the surface plot of the velocity is acting on the surface. You can check. You can even try with other plots, vorticity, and even the pressure and all. The pressure is fine. How much pressure is acting is also matters for me. Yep, this is quite good. Now I just need to cross check the iso surfaces. Let us see. According to the speed, we are looking for 120 kilometers per hour. According to that, let us see how the design gonna just act like. So for 81 kilometers per hour, this is how the drag force will be produced. Sorry, the velocity. So you can activate the transparency mode. So with respect to 81 kilometers per hour, there is no issues. The vehicle will run smoothly. 40 also, it is fine. So as I increase more than 120, there is kind of uh, disturbance or irregularities in the velocity. So to avoid this, I need to have the airfoil structures and the spoilers. Yeah, so let me just hide this. I'll show you the flow trajectories. So here you can refer the rectangle. and you can just adjust it according to the model. And the sizes of the dots, that is pipes, the arrows, you can adjust it, and you could see the preview. The lines need not to be more too precise. Only less lines will indicate the flow pattern. This is fine. You can even change the formats. So let me just showcase how it gonna just preview the results. You can just play it. See, this is how it is acting on the entire model. Instead of pipes, I'll go ahead with the arrows. And if I click on show, this is how it is. You can increase the number of arrows. 250. Okay, 3D doesn't, so it's fine for me. I'll try with the statics. Trajectories. This is okay. You can see. You can just play it to just visualize the flow pattern. After running CFD analysis on the model, we need to validate our results, right? So how we can do it? So that I'll showcase. Yeah, this is fine. The transparency will help me to just visualize the model as well as the flow pattern. You can set it up the values. Instead of 0 kilometers per hour, you can set it to 70 or 80, or depends. Okay. You can try different options just to cross check your results. Velocity along x and max and minimum values I'm defining. Okay, so this is about just flow patterns on the model. You can just play this and see. What I think is more amount of drag is produced at the back end, and the speed came set to 75 kilometers per hour at the back. So we need to make some design changes, or we need to add some extra airfoil structures so that we can achieve more speed when it comes to the track. So as I said, I'm concerned about the drag force. So if you refer some of the case studies on the same experiments, the drag force is approximately 500, but here it is 67. Maximum is, yeah, 67 megapascal. Sorry, Newton. It is kind of reversed. Reversed in the sense the value will be the same thing. Don't worry about it. Yeah. So now what I'll do is to get the drag force approximately 500 Newton, I'll try to include few more structures into the model so that I can achieve the 500 Newton drag force according to the reference papers and the case studies. That is around 550 to 450 to 500 Newton. So for that, I'll just create a new configuration. So this is the initial one. I don't want to change this. Whenever you want, you can just access these results. So as well as one more configuration if I create, whenever I want, I can even access that results. So to do that, I'll start with the assembly. Yeah, I'll close these results. So I hope you got these results. This is the final review on this model. So this is how you can just animate your cut plots as well. Yeah, so now I had created the configuration, new one. So here I'll insert the new part and I'll just click on this and I'll edit this part. So here I'll create the rough sketch of the airfoil structure, that is front airfoil, so that it should avoid the wheel drag force and it should also produce the pedal lift to avoid the drag force. So this is the structure which I'm looking for. Can I adjust it and I'll extrude it. This is fine, this looks good. You can just use kind of opposite entities. I need a certain thickness. You can use the thick feature in extrude tool only, but this will help me to save the time. So just extend this and trim this portion. Yeah. Now I'll go to extrude and only this area I need to extrude it first. I'll remove the contour. I'll select only this portion. It should be both the sides. I'll change it to mid plane. And and extrude it up to the field. It should cover the field. Something more than the field shape is fine. If the structure is fine, so I'll refer the same sketch to draw the side portion. Punch it thin feature, and this thickness I'll take it 10. I'll reverse the direction inside from this surface. When extrude it, I'll reverse it. Yeah, it's the same thing. That's are also needed. We'll do the same thing. Refer the same sketch. Go to extrude. Refer the face, counters, remove everything, and select the area to extrude. Yeah, this is fine. This looks okay. If you want, you can modify these things, but for my convenience, this is fine. This is approximate design. Looks good. So this is the front FL structure to avoid the more drag. I'll create one more part. So here at the back end. So this is the rear airfoil structure. I'll apply the fillet certain amount. I'm just drawing it rough, okay? It is not exactly the perfect dimensions. We're just referring some of the uh, internet images. We can just define it accordingly. This is fine. So here I'll draw inside airfoils. I need 3 membranes. This is the first one. Second one somewhere from here. Yeah, I'll just join it at the corner. And even this should be somewhere here. I'll modify the shape like this. Quite good. One more exactly at the center. Yeah, fine. So I'll just extrude them. So thin feature is active. From midplane, I'll extrude it up to a certain distance. I'll refer the side view. It should be up to wheels. Yeah, so this is fine. Can even select all the edges in one shot. Now I need to make some changes in this design as it is undefined. It will change. So I'll drag and place it properly. So you can fully define it, just select all and just use fix or fully define. Both will work. Yep. So finally, I just need to add the supporting structure at the end. I'll refer the same sketch. I'll close it. Yeah, from surface, this one up to 10 mm inside. This is fine. Same thing that side as well. Even you can mirror it, but this is quite easy instead of mirroring. Yep, this is also fine. The shape is perfectly fine for me. So now I'll just add the appearance for these things. So I'll paste it. For this also I'll do the same thing. Paste the appearance. Yeah. So finally I'll create the configuration. So for this I'll rerun this study because you can clone this. The same study will be there for the current configuration. Green check. Now everything will be configured. You don't need to worry about it. Like whatever the study you have did before, the same thing will be taken into account. Yep. So I'll run the study. So it will take some time again. Yeah. Once it is done, you can just use the same plots which you had drawn for the previous analysis. So these are the plots. So this is the surface plot, the cut plot. This is the trajectories. Just play it once to see how it is. Hide these plots so that you can see the flow. So this is fine. So there is no much drag. The air will be distributed, like it will be taken out properly by using these airfoil structures, and it will produce the more lift, and drag will be reduced. Yeah. To just to verify the results, you can just go to show results. Yeah. So once you free with the results, you could see it is the drag force is around 712 Newton. It should be on an average of 500 Newton. So with respect to the rough design, the rough approximations, these results are quite even the mesh independent civils also works here. Mesh is not so fine. So if you consider these things into account, the results will be approximately near to your requirement. That is like referring to the case studies, it is 500 Newton, so you will reach that particular value. So these results are approximately near to the required drag force for the FSAE car models. Okay, one more very important thing is, so to consider the drag and lift forces, we need to take the appropriate f of x and f of y values. Keep in mind, f of x, that is the force along x direction, will indicate the drag force. Force along y direction will indicate the lift force. So in previous sessions there might be some misunderstanding. To clarify that, you need to remember f of x, the force along x direction will indicate drag, force along y direction will indicate the lift force. Okay, yeah. Yep, so this is how we can just deal with this analysis. So starting from creating the body case and running the analysis without any airfoil structures, and running with airfoil structures, we had seen the differences, the drag force differentiation. I have covered whole thing, like starting from the scratch, how to create the element structures, and then after that I had, like in the right away, I had showcase how to create this term structure by just referring the online documents and running the safety analysis on the same thing to just check the results. Yeah, I hope you understood how to deal with the SolidWorks flow simulation, external flow simulation, to analyze the models by using the all the flow simulation tools, and this is how we can just carry out the simulation on FSAE car. Yep, that's all about this. Thank you guys. Stay tuned. Bye everyone.